Welcome to the Wiener Conference Call series. These one-hour, on-the-record phone calls feature leading experts from Harvard Kennedy School who answer your questions on public policy and current events. Wiener Conference Calls recognize Malcolm Wiener's role in proposing and supporting this series, as well as the Wiener Center for Social Policy at Harvard Kennedy School.
Good day, everyone. I am Mari Mejias in the Office of Alumni Relations and Resource Development at Harvard Kennedy School, and I'm so pleased to welcome you to this on-the-record Wiener Conference Call, which is kindly sustained by Dr. Malcolm Wiener, supporting this school in this way and so many other ways. Today, we are joined by David Keith, who is Professor of Public Policy at the Kennedy School and Gordon McKay Professor of Applied Physics at Harvard's Paulson School of Engineering and Applied Sciences. Perhaps best known for his work on solar geoengineering, David focuses on the complex intersections of climate science, energy technology, and public policy. We're very grateful that he's agreed to share his experience today with the Kennedy School's alumni and friends. David.
Thanks so much. Happy to be here. I'll say a couple more words about my background that might be relevant, and I want to say a word about Harvard's new climate effort, and then I'll say some things about solar geoengineering. So I worked on climate for really, it's the focus of my whole career for 30 years or so, which is probably unusual. And I got involved through kind of an amazing thing that had a Kennedy School connection of a bunch of students between Harvard and MIT who really wanted to work together kind of ahead of their professors, I think, and really thinking about the integrated sense of climate change, of a policy, a technology, and a science problem. And I worked on a big range of topics from real climate science to a lot of things in energy sector decarbonization, CO2 capture and storage technology assessment and the regulation. Also I ended up kind of by accident starting a company, Carbon Engineering, that does direct removal of CO2 from the atmosphere. In order to avoid conflicts of interest, I'm actually not very involved with it anymore, but on the board. And most actively over the last while, but also at the beginning, 30 years ago, I've worked on these topics of solar geoengineering, the idea that humans might somehow deliberately intervene in the climate to reduce some of the risks of accumulated carbon dioxide, but that itself brings a set of new risks and really profound governance challenges. And that work is really the focus of my work right now, but I'm happy to talk more generally about climate. And I'm also serving on the committee headed by Jim Stock that is working to establish a Harvard-wide new climate initiative, and I'm really very excited and encouraged about it. I've been at Harvard about 10 years as a faculty. I was here before, long ago, as a postdoc. And over the years, I and others have wanted a more coordinated action on climate. And I really think that Jim Stock was the right person to lead it. And I'm very excited about the way that's come together. Happy to answer any questions on that I can. So I will show some slides, including some technical ones, but I want to do this relatively quickly because I think on this topic, the questions and answers are really the most useful thing. So I'll go reasonably quickly through slides. Let me get them shared. Oops. Hold on a second, excuse me. We'll get out meeting controls. Oh, I am shared. Okay, sorry, my mistake. All right, so let's start with the thinking about the various ways we can deal with the climate problem. So the the essence of the climate problem is really that emissions of carbon dioxide and some other greenhouse gases that come from economic activity drive concentrations, the total burden of carbon in the atmosphere that builds up over time. The most important single thing really to know about climate is that temperature change and other climate risks are roughly proportional to the cumulative emissions of CO2 over all historical time, certainly over the 20th century. And that means that if you bring emissions to zero, you don't make the problem better, you just stop making it worse. So this sort of thread tells you one way to think about the climate problem. And it also tells you, and I think defines the four ways we can intervene. So the first way, and the way that we can really use the word must, is to decarbonize the economy, to shift the industrial architecture of our society from fossil fuel high emissions system to some carbon-free system, some combination of different renewables. I think solar and nuclear power are the ultimate ways we'll decarbonize our economies. There's all sorts of details. I think there's no question that it's technically possible to drive emissions down eventually to zero, but there are deep questions about how to do it and what the price of doing it quickly is. The second thing we can do is we can remove carbon from the atmosphere. There are a bunch of different ways we can do this, from increasing the carbon concentration in storage in soils or ecosystems, to adding alkaline to the ocean, to these things that the company I founded works on. There's a big range of them. They all have significant costs and environmental impacts. I think there's no question that our first job in the next decades has to be cutting emissions. It doesn't make sense to be spending a lot of effort to pull CO2 out of the atmosphere while we're still belching CO2 into it. But in the long run, the ability to reduce the amount of carbon in the atmosphere is, I think, fundamental to reducing the climate risk. Then there's this thing, solar geoengineering, which acts short term, not on this long stock and flow of carbon in the atmosphere, but it acts short term to reduce climate risks. I'll say more about that. And then finally, all the local adaptive measures that partially break the link between climate change and impacts, by everything from making more drought-resistant crops to something that is simple but profoundly important, is just social methods to get old people out of the upper floors of high buildings during heat waves and protect them from death from heat. So that roughly are the four things we do: decarbonization, carbon removal, solar geoengineering, adaptation. Those are the four physical responses that one can make to climate change. Well, people argue about their names, but I think those are the underlying set. There aren't any more. So now I'll say a little bit about solar geoengineering. It's an intensely controversial topic. I'll say a little bit about why. This just gives you a quick look at some of the methods. I won't really say anything specific about these, but just to say there's a big range of potential ideas, from ones that really I think are kind of somewhat science fiction, the idea that you could build a big shield in space. This is, I think, something that's irrelevant for the next half century, but given that access to space is cheaper, it's not completely insane beyond that. And we've got a kind of century or two scale problem. Everything from that going down in the atmosphere to modifying land surface to make it more reflective. So I'm going to focus most on the thing that we understand the best, which is adding aerosols to the stratosphere, about 20 kilometers over our heads. That's about exactly twice as high as a regular commercial jet flies, and that's the thing that we understand the best, and that's most clear that technically is doable in a kind of crude sense, and there's some evidence that actually could be useful in reducing risks. But before I do that, I want to say a little bit about what some of the obvious concerns are. So this comes from a piece I wrote, and if you want to know more, it was written as a science policy forum in the Science magazine just the end of last year, and it provides my best shot at a kind of an overview in plain language of what are the key concerns about solar geoengineering. And there's really a big range, from a whole set of physical consequences or risks or side effects of an attempt that was at least attempting to act in some version of the global public interest to reduce the climate changes, ideally focusing on those who suffer the most. But even a benevolent effort at solar geoengineering could have profound negative consequences. Then there's a whole set of issues around injustice. And the most obvious one, I think, is a thing that's often called moral hazard, which I think really has two different pieces underneath it. But fundamentally, it's the worry that even talking about solar geoengineering will provide an excuse to avoid the emissions cuts that must eventually be done. And I think one aspect of that is that knowledge about solar geoengineering or talk about it will be politically exploited by self-interested parties, fossil-rich nations, or fossil fuel-oriented companies who will overstate the extent that it works as an excuse to avoid emissions cuts. But there's also a kind of collective addiction phenomena where, in this kind of trade-off between the long-term cutting emissions and the short-term band-aid from solar geoengineering, we all may be collectively tempted against the long-term interests of our children to do a little less emissions cuts now and use the band-aid. There's a bunch of procedural and distributive justice questions. There's obvious questions about whether these tools of manipulating the global environment could lead to conflict. I think the answer to that is not 100% no, but that it's not actually very plausible. And then there's a set of deep questions about what it means for humans to be even more involved in the Earth system and determining the way the Earth is overall. So that's a high-level summary of some of the questions. Now I'll jump to something really a lot more specific. So without explaining much why, I'm going to say that what I believe, and that's just me, is a plausible scenario for using these technologies would be to, at the maximum, use them for something like a couple watts per square meter, which would amount to maybe later this century to undoing a third or a quarter of the total amount that humanity is pushing to warm the atmosphere. And so this slide says something about what would technically be needed to do that. And what's clear is that in a crude way, it's possible to do this with no further research. People know with commercial off-the-shelf methods how you could put materials in the stratosphere. We know enough about stratospheric circulation to have quite a good idea about how this would work. And we can think about some comparisons. Your obvious question should be that it would be insane to put a million or 2 million tons of sulfur in the stratosphere, since we actually know that sulfur is a terrible pollutant. But some comparisons are relevant, and here's a few of them. One is to a natural process. So the Mount Pinatubo eruption in 91 put about 8 million tons in 1 year, one eruption of sulfur in the stratosphere, and had consequences of a sudden cooling, which is different from a long-term cooling. But it also tested the way the system responds. It tested our knowledge, and I think it reduces, gives us some confidence about the limits to the unknown unknowns that could bite us. Because if we watch what the atmosphere did for an 8 million ton pulse, it gives us more confidence, not that we know exactly, but that we're less likely to be completely surprised by what would happen in putting 1 million or 2 million tons a year in. And also it's important to say current global emissions of sulfur in the lower atmosphere, which kill of order 5 to 10 million people a year from air pollution, are about 50 million tons, so much, much larger. So this gives you a very simple picture, one other technical slide of just why it is that when we think about stratospheric solar geoengineering, we talk about putting materials in the tropics at about 20 kilometers, about twice as high as a regular jet flies. So you need special aircraft to do that. The reason is that in the stratosphere, air turns over slowly, turns over about 2 years or something, and tends to rise in the equator and sink towards the poles. So materials you put in will stay there for a couple of years, which is completely different from the lower atmosphere, the troposphere, which is the turning sphere that we live in, where the whole atmosphere turns over every few weeks, and pollution that you put in tends to rain out, so sulfur pollution certainly within a week or so. So first of all, it's worth thinking about what the impacts of such a scenario are, and then we'll talk about what the benefits are. But this gives you some quick look at the impacts, and happy to say more about this. But at this point, it's, in the one hand, we haven't had a serious research program on this topic because there's been a kind of taboo against research, but there also have been kind of mostly done at the little side of people's regular research efforts. There have been now hundreds of papers looking at the consequences, and I think we have some bound to what the consequences of doing this are. And from what we know so far, it looks like the negative consequences of doing this might be quite small compared to the positive benefits. So this is a one climate modeling slide I'll show you. And the background is actually kind of important. As I said, there's been a bit of a taboo against work on this topic. And this came from one of the best climate models in the world, at least at representing tropical hurricanes and the way precipitation works. It's a very high resolution model from the Geophysical Fluid Dynamics Lab, which some of you may have heard about because Suki Manabe, who I spent some time with over the years, won the Nobel Prize this year for his early work in establishing that laboratory, that set of models. So they'd not worked on solar geoengineering before I encouraged somebody to do this. So it was kind of a clean experiment. They didn't have any opinion. They just decided to run their model. We used a method of analyzing the results that is consistent with what the IPCC, the Intergovernmental Panel on Climate Change, has used, in that these regions we picked, we didn't cherry pick. We used some standard regions, and we focused on what are widely understood to be 4 key physical hazards that drive climate risk, where risks are the actual impacts to ecosystems and humans, and physical hazards are the physical changes. So that's changes in average temperature, that's the T symbol, changes in extreme temperature at the hottest hour of the year, changes in water availability, that's the PE symbol, precipitation minus evaporation is the amount of water available for ecosystems and so on. And PX, which is extreme precipitation, basically beats storms that cause flooding. So those are 4 of the biggest drivers of climate change. And then we tag each of these by running the model sort of with the base model, the model with double CO2, and the model with double CO2, some solar geoengineering. And then we can ask, does solar geoengineering moderate some climate variable, that is, move it back towards the pre-industrial, meaning less climate change, meaning for most people better, but that's a value judgment? Or does it exacerbate, meaning move you further from pre-industrial, meaning make it worse? And so then we tag the things about whether they're statistically significant. And the big kind of stunning news here that feels to me like an oversell, I feel almost ashamed showing this, is that there's no bright red symbols anywhere. So for none of those variables in no region was it made statistically significantly worse off? I doubt if real geoengineering would work that well, but this is consistent with what broadly consistent with what a bunch of other models have found. And it's really a kind of stunning result. It may not be true, but it's a reason to take this seriously, that there really is a possibility that doing solar geoengineering could reduce some of the most important climate hazards, especially extreme temperature, which most of all affects people who are in the hottest and often poorest regions of the world. And for what it's worth, the one model that actually seriously investigated what the distributional effects would be of solar geoengineering found that it would dramatically reduce intercountry income inequality because it increases growth rates that would otherwise be depressed by high temperatures in the poor parts of the world and doesn't really do much or even depresses growth rates in the hottest part and the coolest parts of the world. Maybe I'll actually skip over this in interest of time and talk about how these things might fit together. So I started my talk talking about these four instruments, and now I'll say a little bit about how they may fit together and then really look forward to questions. So first of all, if you just emit CO2 forever, climate risks grow without bound. That's the single thing to know about climate. And if you eliminate emissions, and we'll have presumably global celebrations the day that net emissions cross zero, if you eliminate emissions, very different from eliminating air pollution, where if we eliminate air pollution within a week or so, the air pollutants are gone from the atmosphere. If you eliminate emissions, you don't make the problem better, not in any policy relevant time scale, you just stop it getting worse. If you do this carbon removal, you can make the underlying problem less bad. You can pull the carbon out. But my view is that carbon removal makes most sense done slowly, done as a way to gradually get us out of the hole that we've dug for ourselves as a species, because carbon removal cumulatively removes CO2, but if you try and do it very quickly, the environmental impacts of that removal themselves become pretty important. However we do it, and I have versions of this with numbers from integrated assessment models that build on Nordhaus's model. I won't even show them. This is just a sketch, but the key thing is how you would use solar geoengineering. In my view, is you use it to slice the top off. So you use it in a way that you gradually ramp it up, where the peak amount of solar geoengineering is roughly at the time where there's peak concentrations of carbon dioxide, which are where the climate risks are peak, and you use it as a supplement to the other measures, as a way to reduce total risk, but not as a substitute, not instead of cutting emissions or carbon removal. So that's kind of the rough way I think about it. And this has important consequences for timing. So many people think of carbon removal as much safer and more urgent. It gets much more policy attention right now than solar geoengineering. Despite my even financial interest in carbon removal, I actually think the evidence is that if you want to reduce temperatures mid-century, basically to supplement whatever we do for emissions cuts and reduce temperatures, then solar geoengineering and carbon removal are kind of substitutes. They both can do that. And that carbon removal actually may be more risky and have higher side effects if you try and act that quickly. And you can see a little bit here about the timing. One kind of lesson of this story is that carbon removal really mostly wants to start after emissions are near their peak. Whereas solar geoengineering, if we want to use it at all, which I don't think we know, there are deep reasons to be uncertain, you actually want to start relatively early because you want to be able to ramp it up well before you get to the emissions peak. That's really the key lesson from these slides, that you would actually want to start solar geoengineering in this kind of optimal policy sense before you start really large scale carbon removal, which isn't to say you don't start learning something and actually trying technologies now. That's all I want to do for slides, and I'm really happy to take questions about this or about climate change generally. I'm lots of energy and policy questions interest me, or about the Harvard program. Thank you very much for listening.
Great. Thank you very much, David. So we're going to open it up for your questions. If you would like to ask a question, please use the virtual hand raising feature and you'll be notified that it's your turn to speak. Make sure to unmute yourself. Finally, our participants would really appreciate it if you could state your Kennedy School affiliation. So I'm going to start things off by asking a question that had been submitted earlier by alumna Claudia Silva, mid-career 1999. And that question is, would small businesses be able to apply any of these new technologies? And if so, how could they go about this?
So, what new technology? So solar geoengineering, I think, is in general not something that any business should be having as part of its business strategy. I think if we decide to do this, it'll be decisions that nations make, and they will employ commercial supply chains to do it. But I think the decisions about doing it ought not to be business-driven decisions. It's fundamentally a risk-to-risk decision where there's risks of doing solar geoengineering and risks of not doing it. I don't think it should be driven ultimately by business interests. For carbon removal, there are businesses doing carbon removal. There are businesses that will sell you biochar that will supposedly remove carbon, probably not very effectively. There are a bunch of little businesses in the carbon removal space and bigger ones, including that one that I was involved in founding. I think there is significant interest now in people understand that so-called carbon offsets are mostly not very real, but the carbon offsets from these technical methods of carbon removal would be real. It'd be expensive, but real. So there is a surprising market at the level of, it seems, billions of dollars for companies that want to offset their carbon emissions. And so there's conceivable that small companies would want to do that. Obviously, there's lots of other climate technologies where companies can be involved in installing solar and wind or heat pumps or what have you.
Thank you. Vinny Flores, you're up.
Thank you so much. Thank you so much, Professor Keith. I would like to ask you about mining. As you know, all the estimates and forecasts that we have made end up saying that the emphasizing the critical role of minerals in the clean energy transition.
Yep.
Remember, I mean, you come from Canada, obviously a very well-known country, top country in mining. What can mining companies and other stakeholders do in such a way to mitigate the tremendous footprint? Because also mining companies, have quite a presence in respect to carbon emissions. So what can we do so the savers of the world, as somebody calls them, really save us and not just exacerbate the critical situation? Thank you.
So first of all, I'd say I think there's some overhype about how much critical minerals will end up mattering. I think it's worth thinking back to this famous bet between Julian Simon and Paul Ehrlich about prices of natural resource commodities. I think there tends to be more substitution than people imagine. And there's also more role for technological change in changing what resources or what reserves are exploitable. So I think if the history of obviously fossil fuels, but also many minerals has taught us anything over hundreds of years, it's that we should be suspicious of kind of simple extrapolations of reserves to production ratios that suggest that there's a big mineral crunch coming. And I think that's going to be true here too, both for the substitution reason and for the change in technology supply reason. But that said, there's no question that some minerals we're going to need a lot more of for the clean energy transition. And we absolutely need to think hard about the environmental and social impacts of mining. I don't have any one-size-fits-all answer, except that I think that there are ways in which countries that have strong environmental standards can attempt to export those standards by essentially imposing on any imports demands of those imports that their supply chains meet the same standards as would be applied in the country. And I think that can be true for labor. I mean, this is built on the dolphin tuna case that essentially makes it allowed under the WTO rules for one to make a regulation on the supply chain as long as it's the same regulation you'd apply to yourself. This is obviously very important for carbon as well. So I think that's an international policy answer. I mean, the specific answer is there are often trade-offs between the amount of disruption and cost, and we need to be willing to pay a little bit more to get less disruption. That's very generic. Hope that's helpful.
Thanks very much for that question, Vinny, and answer, David. I'm going to ask a question that Mike Putnam, MPA 2004, had popped in the chat. who's now working on climate change. And the question is, what could be a workable process for the international community to decide to test this out or try it out? And can the international community prevent rogue actors from doing this independently without broader agreement?
So we need, I mean, right now the dialogue of this is highly fractured. So there are a set of relatively small, but very vocal and effective actors on the kind of progressive left who really believe that there should not be research on solar geoengineering at all, and will argue that people like me are geoengineering profiteers. To be clear, I actually do zero commercial work on solar geoengineering and have advocated that there be no commercial work. But the dialogue is really fractured, and there's a lack of serious participation from developing world scientists. It's growing, but there's not enough. I think there's no simple answer, but what we need, I think, is more dialogue that gets this out of the small number of actors, of civil society groups that have very strong opinions one way or the other, and bring it more to the mainstream of the climate and environmental debates. One step towards that, as an example in which I'm somewhat involved, is there's a formation of a global commission modeled on the Global Oceans Commission, for example, which will address broadly the governance challenges of so-called overshoot. So that involves both solar geoengineering, carbon removal, and adaptation, but in a way that probably will focus some of its attention on solar geoengineering. And that will be probably a higher level look than has ever happened before in terms of the people who will be on the panel. So I think that may help to bring a kind of balance to the conversation, because it won't be people who are sort of insiders to this little solar geoengineering debate, but people who are major figures in international politics. I think that's one step. I think the rogue actor concern, I was probably one of the early people to raise it. I think we have now done a fair amount of analysis, and the more I think about it, the less I think it's a threat, not because I think that somehow countries are infected by benevolence. Indeed, obviously on a day where we're worried about war in Europe, that's a pretty ridiculous claim, but because it's not obvious that they're, just from the pure self-interested point of view of a potential unilateral deployer of solar geoengineering, it's not obvious that there'd be benefits to do that. Solar geoengineering probably works best if it's done pretty evenly. The added cost of doing it pretty evenly is small. There don't seem to be ways to do it that really provide big benefits to one place and disbenefits to another, which, to be clear, if that was possible, countries would presumably pursue it. And also, well, because of countries' rational understanding of the ways in which other countries might push to stop them, a country that wanted to deploy unilaterally would, I think, be incented to put together a coalition. So I think it's a reasonable worry, and I think there are ways we could reduce the risk by something that looks like a moratorium, or some kind of set of agreements by major powers that set out prohibitions against unilateral action, set out procedures for early notification, and so on. I think the last thing you addressed was testing. I think testing is not, in some sense, the right question here. This is about a large-scale intervention in the Earth, and there's some way in which we never test that full intervention, as we never also test what happens with CO2. What we need to do is a whole lot of experiments that collectively will reduce some of the technical uncertainties. And we're pursuing such an experiment at Harvard. There are a bunch of others. Those experiments would gradually improve our models, reduce the uncertainties, but they're not really tests in a kind of binary sense of how the technology will work.
Great. Thank you very much for that question and answer. We're going to go to Nancy Zwang, who I understand is Master of Public Policy.
Yeah, class of 78. Follow-up question on that. You mentioned global commissions, but you didn't mention the UN. Would that be part of what you feel is necessary for creating a global consensus? But my original question was, in your graphs, simplified as they are, there's probably a lot of assumptions, and the ability to forecast exactly when things are rising and could potentially decrease. But there's so many, from what I've read, there's so many ways in which there's unexpected sources of big surges of methane or carbon, such as development of peat areas and things like that, or the tundra, the permafrost defrosting, things like that. So how confident are you really that people would be able to time the intervention in such a way that it has the benefits that you're talking about? And the final question I have is, with all that sulfur released, is that going to bathe the entire world in acid rain with all of its accompanying disadvantages?
Let me try and go backwards. So the last one is the very easiest. So even the most critics with this would agree the answer to your last question is no. And that's really there in the numbers I said. So if you put 1 million tons a year of sulfur in the stratosphere, that million tons will all eventually come down to the ground, but it's pretty even. Acid rain is really due to the local concentration of sulfur, especially in some areas that can't handle it well. And those local concentrations are much, meaning factors of 100 or 1,000 times bigger than from this. Because as I said, right now we've actually decreased a lot, but right now we're at 50 million tons a year in the lower atmosphere, all of which is going to acidic rain. And so this would be changing it by 2%, but also 2% in a way that's very evenly distributed, whereas the acid rain was mostly close to places with peak emissions. So I think that's pretty clearly not an issue. There are a bunch of ecosystem risks that are real, and we don't have any way to know them for sure. All I can advocate is that we use the best environmental science that we have, and that we focus most of all on understanding what the potential big risks are, and if you like, evaluating the unknown unknowns. That's what I advocate for in a research effort. And all we can say is that so far, people have at least looked at this. People who are actually quite critical published a paper on the acid rain thing and came to the conclusion I said. And we've published papers, and several groups have, applying existing climate and environmental science to look at various ecosystems effects on food systems, effects on air pollution. And at least so far, all those studies show that the effects are pretty small, which doesn't mean we know all the answers, but it is what we know so far. You asked a question about timing, that how would we, that because of uncertainties about, say, feedbacks of methane in the Arctic, we wouldn't know exactly when to do it. I don't think there's any reason we need to know exactly when to do it. We're talking about a small add-on to what else is happening for climate. And I don't see reasons why the timing is particularly sensitive. So if it was true that there was a feedback, as might be true, with rapid methane releases from thawing permafrost, that's still a very small add-on to this cumulative radiative forcing. And solar geoengineering would presumably act quite quickly actually to reduce that by cooling permafrost. So I don't think, I'd say there are a lot of things that are wrong with this, but it doesn't depend on assumptions about timing in ways that are sort of, it doesn't assume that we have some kind of magic knowledge about exactly when different feedbacks in the climate system will be relevant.
Great. Thank you very much, Nancy, for that question. So now I'm going to read a question from Doug Ogden, who is MPA 1995. And he was wondering if you could lay out a potential implementation scenario for global solar geoengineering.
Well, I mean, in terms of the progression over time, that's kind of what I showed. And we have a version of the Nordhaus model that actually showed the graphs I had with values on them. But I think the key is that you don't just turn it on. In fact, I think I would always vote no on that. The key is that you start it up very slowly, and there's ways you could watch for some kinds of unexpected chemical effects in the stratosphere that you could stop early on. So I think there's an argument for starting very slowly. As to how it's done politically, I think a lot of political discussion about this is caught between two kind of ridiculous poles. So on the one hand, as some of you may know, a prominent group of social scientists just issued a kind of call for essentially banning research, saying that there should be no public funding for this anywhere in the world, that there shouldn't be assessment by the IPCC. I mean, effectively, they try and say they're not banning research, but that's what they're arguing for. And their argument is that it's fundamentally ungovernable. And if you look at their paper, they really say it's ungovernable in a way where there's even global participation and where governance means that everybody's consulted and so on. And I think the answer to that question is, yeah, it's ungovernable by that standard, but so is everything else. So by that standard, we also would have to ban the internet mRNA technologies and all sorts of things that also have profound distributional effects and can be, many of them, exploited for warfare in ways that this can't. And we govern them in a way that's highly imperfect today. So on the one hand, we have this kind of idea that we shouldn't implement any new technologies unless we have some global governance that is just in various reasonable ways. On the other hand, we have a kind of concern that a rogue actor will just do it. My sense is the real world is much more in the middle. We actually do, as a species, govern lots of things highly imperfectly, but we sort of do. So we didn't manage the pandemic very well. I think in hindsight, the Western world really completely blew it by not spending tens of billions of dollars early on to build a bunch of production lines for mRNA vaccine that should have happened. But on the other hand, there actually was collective action. The fact is the Chinese did publish the sequence at the beginning, and we were able to develop vaccines, the first vaccines within weeks of that sequence from international scientific collaboration. And we collaborate around all sorts of things, from asteroid defense to avoiding nuclear war, all imperfectly, but not with a total failure. And my sense is solar geoengineering will be governed in this middle way. It won't be done by having a perfect governance system, but it won't be a unilateral rogue actor. Actually, to come back to a question the earlier person asked, I do think there's a profound role for the UN and for the Framework Convention on Climate Change, but I think there are ways in which those things are inflexible. And the reason that we're pursuing this global commission, as per earlier global commissions like that one on the global oceans, is these global commissions often have a lot of people who are tightly tied with the UN system, but they do it slightly outside the UN system because then they can be a little more nimble and suggest governance fixes that the UN is not very effective at addressing, as was true with that Global Oceans Commission, which addressed risks outside the 200-mile limit. So I think something like that for solar geoengineering could get to some set of principles that would be not perfect, but not terrible. And I think if it's implemented, it would be implemented by a set of countries that could gather enough legitimacy that other countries that might not be so supportive would not be hostile. So I think that would need to be a set of countries from rich and poor. It would need to be some reasonable range of countries that could articulate clearly stopping rules and transparency. And I think there are versions of that you can imagine, but you could also imagine terrible versions.
Great. Thank you very much for that question and answer. So now we're going to read a question from Jose Enriquez, and he is PhD 2021. So if carbon can be taken as an element of the periodic table, giving it a different use to reduce pollution and be able to use it to market as a development strategy, it can be taken as a financial asset so that financial value is generated in an electronic currency, as in Mexico, for example. Is this feasible?
I don't really, there are a lot of people who seem to say something like this, and it may be that I'm just old and I'm not getting it, but I don't get it. Our problem with climate is like our problem with open sewage 100 years ago. People are using the atmosphere as an open sewer for the waste products of industrial humanity. We are dumping 40 billion tons a year of CO2 in the atmosphere. And the problem is basically that people are allowed to use the atmosphere as a free waste dump for their carbon. And yes, there are, of course, uses for carbon, as there are uses for things we extract from human excrement. But I don't think you make a big, you don't solve the human excrement problem by profiting from the waste. There were tiny examples of that, but fundamentally you need public policy that serves a collective action problem to enable a public good. And that's how we built sewers and public sanitation. And I think CO2 emissions are a bit like that. I think that I don't see how this kind of private action that sort of sees carbon to value is the buzzword, kind of really does that much to solve the problem on our own. I think in the end, this is a thing where government action to fundamentally penalize using the atmosphere as a waste dump is central.
Great, thanks very much. So now we're going to go to Charles Glazier, MPP 1981, PhD 1983, who asked in the chat, given the current level of damage from climate change, he sees a strong case for starting geoengineering as soon as basic experiments are completed. Why not sooner rather than later?
Fair question. I think I think that the challenge for the world decision makers is to figure out who to believe. So if you Google through the press on this, you'll find that Bill Gates backed Harvard scientists are trying to block out the sun for profit. That is pretty close to word for a Guardian headline. And the fact that it's not true doesn't really help in the world where it's very hard for people to figure out what's true. My read of the science so far, which is not huge, but it's not tiny, is that there are ways that one could geoengineer by putting aerosols evenly in the stratosphere, a relatively small amount, where from the evidence we have, there would be environmental risks and there are uncertainties, but the benefits, particularly the benefits to some of the poorest in the world by reducing heat in the places that are hottest, those benefits would be pretty big. Indeed, this one study that looked at the distributional benefits or distributional impacts of solar geoengineering found that doing it could substantially reduce intercountry income inequality because high temperatures drive down economic activity and kill people. And they do it most in the hot regions that are poorest. So a world with solar geoengineering might be a world with less inequality, quite literally, than a world without. So my view is there's actually quite a strong argument from what we know so far for moving with deliberate pace towards doing it. But I wouldn't advocate doing it now because there really has not been enough research, and especially not enough research by enough different groups. I think there's a danger of groupthink by people like me. So my near term, what I advocate is a much broader research effort. I think we can make quick progress because this isn't, well, it's sort of a new technology. It's really applying existing environmental atmospheric science to a new problem. And I think we could have a much broader effort, globally diverse effort with people from the rich and poor world. I've just spent time this morning talking to the head of the meteorology department at IIT Delhi, for example. We have a much broader effort quite quickly that could have efforts to really look at ways that people like me might have been wrong, to beat down the groupthink. And I think you could really quite quickly, in 5 years or something, significantly reduce the kind of uncertainty about what's known so far by broadening the research effort. And then from there, with luck, one could develop some legitimate ways to begin inching towards decisions about implementation, decisions which I could still see going either way.
Great, thanks very much. Just a reminder, if you'd like to ask a question, please raise your hand or pop it in the chat. We're next going to Gary Grimm.
Hello. Is there a way to transition this out of academia into industry? Or do we need Bill Gates, Jeff Bezos, Elon Musk to fund things so that we can perhaps bypass government and start the experiments you mentioned more quickly?
I think that would be a terrible idea. I think in a world that is justifiably more skeptical about the gentleman you just mentioned, if we just decided to take money from those gentlemen and rush ahead, it would blow up. And people would be justifiably regarded as completely illegitimate, as some people already do with what we're doing. So I don't support that. I think it's crucial that a bunch of the money and decision power be democratic and be, that means distributed and partly in the hands of a range of democratic governments. I do think there's a role for private money, and I've raised private money at Harvard, but with strong checks and balances that allow us to do some of the research that we do, but there's also public funding. I think that I guess one thing to say is no, I really don't think there's that much role for industry. I think this is crucially an issue about trust in science and the scientific results. It is true that if we actually get closer to implementation, there's an industrial role for developing the aircraft and the delivery systems. But all the evidence is that that's not particularly hard. It's something within the ambit of what the global aviation business already knows how to do. And I think that should be done in a way that's a kind of cost plus contracting where governments retain control over what's done. I think capitalism works great when we're competing to build products cheaply, but it's easy for independent people to judge the safety of the product. And that will never be true for something like solar geoengineering. So I think that it's really important that the information be open in the way that open science can be, so that it's open to scrutiny. I think that we justifiably don't trust companies when they make assessments about safety of very complicated things where it's actually hard to have any independent assessment. And that's why I think the role for international science and environmental oversight is so crucial.
Great. Thank you very much for that answer. Now we're going to go to Roxanne Kaysen, who was just wondering about AI and machine learning and how does that power the research, if at all?
Not much is the answer. ML is such a hot topic these days. I've got endless emails of people, even people who want to like drop their ML jobs and come work for me. There's not much use for the stuff I do. There is a growing use for climate modeling broadly. There's a clever application of ML to deal with what we call some parameterizations of clouds and other things that I think will improve climate models, not dramatically, but they will improve them. But all these things doesn't seem like there's obvious uses for ML, but maybe I'm just old-fashioned and not getting it.
Thank you very much. So DG has popped a question into the chat. So the question is, how much is your best guess estimate for the cost of doing the experiments year by year for those 5 years necessary to reduce the unknowns and come to a more certain tentative conclusion one way or the other if the benefits outweigh the risks of solar engineering?
So the experiment that we've worked on at Harvard, a balloon board experiment called the Stratospheric controlled perturbation experiment, that has a budget of order a few $1 million to get started, and to really pull that experiment out, if you're really going to learn something for a bunch of years, you'd have a series of flights and the budget would be a couple times that. But that's only one experiment. There's a whole bunch of other experiments that are worth doing to understand for stratospheric solar geoengineering. There'd be experiments with stratospheric existing aircraft, and there are existing aircraft that could be very effectively deployed to try and understand better the way aerosols form in a plume, the way they mix, and so on. There's a bunch of work to be done developing better observation systems that are targeted to this. I think in total, if you count by experiments, meaning observations, not necessarily releasing anything, but developing more of the scientific capability to monitor, I think it wouldn't be inappropriate to spend several percent of the total budget for climate and atmospheric science, which globally is sort of 10 billion a year. So, to spend, to ramp up to a couple $100 million a year, which is roughly what the US National Academy recommended, but scaled globally, I think would be very reasonable. And to put that in perspective, this is all tiny money compared to the amount of money we are or ought to be spending to cut emissions. So humanity is now, by Bloomberg New Energy Finance numbers, spending maybe $300 billion a year on clean energy. And my view is we should be spending more like $1 billion, close to 1% GDP or higher, actually. $1 trillion, close to 1% of GDP or higher. So this is all really small money, even compared to atmospheric science, which itself is tiny money compared to the emissions cuts. So the issue really isn't about total money, it's about legitimacy and transparency.
Thank you very much. So we have another question in the chat from Jonathan Williams, and that is whether there are concerns that geoengineering will only tackle warming might neglect other concerning effects of greenhouse gas emissions, notably the issue of ocean acidification. Are there geoengineering options that are realistic and might address the acidification risk?
So a common misconception, first of all, is that solar geoengineering somehow is just about temperature. So it reduces climate changes broadly, as I showed you. So it'll reduce sea level rise, it'll reduce changes in water availability and peak temperatures and so on, and actually has a small effect in reducing carbon concentrations and therefore ocean acidification, because it reduces some of the feedback. So that was actually the slide I skipped over. Somebody asked me earlier about Arctic methane from permafrost, for example. So if you have two worlds that have both the same human emissions of CO2 from industry, and one world has in addition some solar geoengineering, so the temperature is lower, the world with the temperature lower will have less of those feedbacks, and so actually have less carbon in the atmosphere at the end of the century, and so a little bit less ocean acidification. actually, it turns out that coral bleaching is both about CO2, but also about peak temperatures. And so there's several papers that show that solar geoengineering could significantly reduce the coral bleaching problem, although in the end, it's clear that you can only deal with that problem by stopping putting CO2 in the atmosphere. So this is just a Band-Aid that buys you a few more years. You have to stop putting CO2 in the atmosphere. There are a separate set of carbon removal or carbon geoengineering ideas, such as adding alkalinity to the ocean, that can really remove carbon from the Earth system in a way, or remove it from the dangerous parts of the Earth system, and would deal with ocean acidification. None of those are investigated very seriously, and I think they would require a different kind of scale and have a set of environmental impacts that need investigation, but I personally think it'd be worth putting more effort into.
Great, thank you very much. So I have just kind of one final question, and not to put you on the spot, but just wondering whether you have any optimism that this problem will be solved, maybe if not in our lifetime, or what are your thoughts on that?
Yeah, you can ask me. It was a good question last time. I mean, I think resolved is the right word, not solved. So I think it is important to say that we made this, the world in lots of ways have made huge progress on a bunch of environmental problems, on global ozone, on toxic metals like lead or mercury, on air pollution, not just here, where in the US, the Clean Air Act has added more than a year and a half to the life of average Americans with a cost benefit ratio that's sort of around 10 to 1. So we have made huge progress on water pollution and now also in some of the parts of the world that were poorer. China has dramatically improved air quality in the last while. So I think we have done these things. But in all those cases, we've done them slower than we should have done them. And lots of people still die from air pollution. And while we are increasing the amount of land that we protect, for example, globally, we still have, in my view, much too high a footprint on the landscape and are not doing enough to preserve the natural environment. So my view is that there will be a point where climate change is something in the rearview mirror, but a lot of damage will be done in the meantime. I don't see climate as, I don't think it's, to me, that useful to talk about as a kind of existential threat. I think we actually have existential threats, which are mostly human on human violence, with nuclear weapons or biological weapons, or maybe armies of robots. I think quite serious concerns. I don't see climate in the same regime, but I see a difference between worlds where we act much too slowly and we still will survive as a species, but we will have damaged a lot of people, damaged people's lives and killed them from heat and from high temperatures that make it hard to learn. That's not a theory. We have really good epidemiological data for that, and damaged the environment, giving less of our beautiful environmental heritage to our kids, or a world where we do more on climate and we can pass a better world on to our kids and have more people who are now alive have better lives. And to me, that's the fight, and it's not won or lost. So I'm optimistic that it's possible, but clearly the world is having at a time where it's much harder to collaborate globally, and many of the failures of COVID policy don't give you a lot of confidence about our ability to collaborate as a world now. And clearly a level of geopolitical tension today doesn't give you a lot of confidence on our ability to collaborate on these global problems.
Great. Well, thank you very much. And thank you to everyone who called in to listen to this Wiener Conference Call. Special thanks to David Keith. Our next Wiener Conference Call will be held on March 22nd, featuring Iris Bonet on unconscious bias and diversity, equity, and inclusion. Thanks again to everyone. Have a good rest of the day.
Thank you so much.